Hi, and welcome to section 9.4, which is it's our review for polar coordinates. The same thing we did last year in section, I believe it was 10.7 and 10.8. So it's that brief but thorough review of what we did last year. All right, so let's get started. We've got rectangular coordinates, okay, which are in the form of x, y. And that point where you start everything is called the origin, 0, 0. Now, polar coordinates are in the form of r, theta. Now, there are some rules here. R is that directed distance, okay? Means you're going toward the angle, it's positive. If you go away from the angle, then that is negative. And we're going to graph a couple points so you can remind yourself of what did we do last year. You'll be there. Okay, so theta is that directed angle, and look at this, must be in radians, so no degrees, please. Now, polar coordinates has its own form of the origin. It's called the pole. Okay, now it's called the pole. You can understand that when we get to the picture of the graph. Okay, it looks like the North Pole, get it? Okay, anyway, so when we're graphing these points, I know this is kind of a little bit blurry, but I think on your notes it's a little bit better. So when we go to graph point 1 here, now even though it's in the form 3 comma 2 pi over 3, we really kind of do the second coordinate first. So we locate that 2 pi over 3 line right here. Now if it's a positive 3, we go out toward that 2 pi over 3. If it's negative 3, we would go away from it. Okay, so ours is a positive 3, so I'm going to go out to it. So 1, 2, 3. There's my point number 1. Okay, let's change our color and see if we can figure out what point number 2 is going to look like. Okay, so we locate our pi over 4 line. Okay, so it goes pi over 6, pi over 3, pi over 4 is right here in between. So I'm going to start at the pole. If it's a positive 2, I'm going to go out 1, 2 toward that pi over 4. If it's negative 2, I'm going to go away from it. And it happens to be a negative 2, so I'm going to go 2 away from it. So really, I'm on that pi over 4 line, but if it's negative, I'm actually on that, what line would that be? So it's on that, that 5 pi over 4 line. Okay, so that pi over 4 and that 5 pi over 4 line are really linked together. Positive, you're going positive 2 comma pi over 4, you're going toward the pi over 4 line. Negative 2, you're going away from it, so you're actually headed towards the 5 pi over 4 line. All right, so let's just do a couple more. We've got a couple more colors we can change to. So this little guy here, we're doing 1 negative pi over 2. So pi over 2 would be this guy, negative pi over 2 is this guy. So negative pi over 2, it's the same as that 3 pi over 2. So positive 1, we're going out towards it, 1 spot. Okay. Now, if we do negative 1 pi over 2, let's look at that one. Okay, so here's my pi over 2 line. Positive 1 would go this way, negative 1 goes this way. So, that's kind of interesting. These are finding that polar coordinates are not unique. Rectangular coordinates are, but not polar. Now, when I go to graph 2 comma 3.5, we would be estimating where that 3.5 was and going out towards that line. So it's not going to be on one of these nice pretty lines, okay? But if you're going to be graphing this on your own, it's going to be a special angle, so it will be on one of the pretty lines. All right, so polar coordinates are not unique. You can get to the same point using many, 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 many representations of it. In fact, you can do 2 different methods, okay? So what you can do is go all the way around the circle, either in the positive direction or in the negative direction. So you don't have to change the R. but you have to add or subtract 2 pi, 4 pi, 6 pi, 8 pi, etc. If you don't want to add or subtract 2 pi's, you can change r to the opposite and only add or subtract an odd number of pi's. So 1 pi, 3 pi, 5 pi. So it's kind of like a shortcut by doing the opposite of r. That way you only have to add or subtract 1 theta. It truly doesn't matter what you do if you're asked to give more representations. Now normally they will give you a representation and ask you if it's correct or not. So you just have to know that you can either leave r alone and add or subtract 2 pi. So I could have 3 and then 5 pi over 4. Or I could have 3 negative 11 pi over 4. So all I did was add and subtract 2 pi here. Okay. Or I could change r to the opposite and then just add 1 pi. Or subtract 1 pi. Okay? It's up to you. All of these representations are perfectly fine. Now we can open this up and even add and subtract 4 pi, 6 pi, 8 pi, any even number of pi's. So if you want to go hog wild and add and subtract 100 pi, knock yourself out. I would probably stick pretty close so the numbers are nice, but hey, that's just me. Okay, so we are going to be converting from polar form to rectangular form and then back. If you are going to rectangular form, remember rectangular form has one answer, only one representation, you are done. So x is going to equal r cosine of theta, y is going to equal r sine of theta. Okay, x comes before y in the alphabet, c for cosine comes before s for sine. Okay, just kind of think of it that way. You can also draw your triangle representation. You'll get there as well. So only one representation. Now, if you get to use a calculator, of course, it's going to be an angle that is not exact. So you're going to have lots of nice little decimals. Usually this is going to be in the no calculator section, and it is going to be a special angle. So therefore, you might want to brush up on your SOHCAHTOA and your special triangles. Now, when you are converting from rectangular to polar, there are an infinite number of answers. So I'm just going to ask you to find 2. I think that's reasonable. Now, when you want to find that directed distance, okay, that's that distance from the origin, so that's going to be the square root of x squared plus y squared. Theta is going to be inverse tangent of y over x. Remember, theta has to be in radians, and make sure you graph your point first. So graph point first. If you don't want to graph it, at least figure out what quadrant you should be in so you get the correct theta written down. All right, so here we go. Polar to rectangular. Only one answer will do. So x is going to equal 2 times the cosine of pi. Y is going to equal 2 times the sine of pi. Don't use your calculator because the answers have to be exact. Okay, so pi, just think about your graph. Okay, cosine starts up in the 1 position, then drops to 0, then goes down to -1, which is where you'll find pi at -1. Sine of pi is 0. Now make sure that you are now putting it into the form of a point, so don't go this far and then not put it into a point form. 2 times -1 is -2. 2 times 0 is 0. Okay, now on the next one, we do have to use our calculator because -1.5, that is not a special angle. So we will literally just plug it in our calculator. Now, before you plug it in your calculator, what must you check? If you said mode, you are correct. Please make sure you're in radians so that you get the correct answer. So make sure you're in radians and then literally just put in -3 times cosine of -1.5. Hit the enter button and you've got the magic that is -0.212. Do the same thing, negative 3 sine of negative 1.5. It's going to give you 2.992. There's your point. It's a doozy. Now let's do one last one because we are on it. So x equals 4 times cosine of pi over 4. Y equals 4 sine of pi over 4. Cosine of pi over 4 is square root of 2 over 2. Same thing for sine. Simplify as low as you can go. And there it is. Whoop, there it is. Oh, mercy, I'm so sorry I said that. Okay, now we're going back and forth. So we're going from rectangular to polar. We're going to find 2 answers. Oh, mercy. Okay, so remember the first thing you're supposed to do is figure out what quadrant you're in. So you're graphing this point, you're going 2, negative 2, so you're in the 4th quadrant. So please remember that when you go to find your angle. Your theta is going to be inverse tangent of negative 2 over 2. Don't touch that calculator. I see you. Okay, so that's going to be negative 1. So what angle has a tangent of 1? Okay, well that would be 45. So the reference angle is 45, which is pi over 4. Now you need the angle in the 4th quadrant that uses 45 or pi over 4 as its reference angle. So that would be 315, which is 7 pi over 4. Okay, so we could have theta equals 7 pi over 4. Okay. And then r is going to be the square root of 2 squared plus negative 2 squared, which is going to be 8, so that's 2 square root of 2. So when I go to find my angle, I go 2 square root of 2 because it's r theta. Remember, r, theta starts with the t, so r comes before t in the alphabet. It's just like x, y. It's all alphabetical. That's not really why they did it, but it sounds good and it's easy for us to remember. So I've got 7 pi over 4. I need to find another representation of this point, so I can subtract 2 pi, I can add 2 pi, whatever you want to do. If you want to change this to negative 2 square root of 2, you can add or subtract 1 pi. I've already written down the r, so I'm just going to go ahead and subtract 2 pi. Okay, so number 11. I know I'm negative and negative, so I'm in quadrant 3. So when I go to find theta, I'm going to have inverse tangent of negative 5 over negative 5 square root of 3. If I simplify that, I'm going to have 1 over square root of 3. Which reference angle has a tangent of 1 over square root of 3? If you said 30, you are correct. Remember, that's pi over 6. Okay, so I need the angle that's in the 3rd quadrant. So our theta is 7 pi over 6. So that's why it's really important for you to know what quadrant your point is, because you don't want to accidentally put down the wrong angle, because then your other representation's not going to be right, and it is not going to get any better. So negative 5 square root of 3 squared plus negative 5 squared. If you don't get to use your calculator, let's practice squaring together. So negative 5 squared is 25. Square root of 3 squared is 3. Negative 5 squared is 25. So I've got 25 times 3 plus 25, that's 100. Square root of 100 is 10. So when I go to write my point, I've got 10 comma 7 pi over 6. And then I can write another representation of that point. We can do, let's do negative 10. That means I'm going to either add or subtract 1 pi. So let's subtract 1 pi. That way we'll have pi over 6. Okay. Now do number 12, and I'll give you the answers to those tomorrow, because we got things to do. And those things we've got to do are to convert whole entire equations. So we converted points back and forth from polar to rectangular. Now we're going to convert equations back and forth. Okay, so we're going to use the same information we used to convert points, only we may be looking at them with fresh new eyes. For instance, theta is equal to inverse tangent of x over y, of y over x. We may need to look at it as tangent of theta. That's equal to y over x. We have r equals the square root of x squared plus y squared. Maybe we don't want the square root. Maybe we want to replace r squared. So we've got different versions here that we can work with. We would like to have it solved for y if possible. If it turns out to be in one of our special forms, one of our special conic sections, like a circle, an ellipse, or a hyperbola, then of course we'll leave it in that form rather than solving it for y. All right, so on number 13, we've got r equals 2. So r is equal to the square root of x squared plus y squared. So we're going to sub it in. And then the square root, kind of gross, so we're going to square both sides. That's a perfect circle. That's a perfect equation. Not going to solve that for y. It looks better as it is. Okay, so now to the next one, theta is equal to pi over 3. So theta is the inverse tangent of y over x. That's equal to pi over 3. Now, when you're thinking about, do I have this solved enough? I want you to think about, if I was in Algebra 2, would this equation scare me? The answer to that question would be yes. So keep solving. Well, I've got an inverse tangent. That's kind of scary. Heck, it was scary to us last year. So I'm going to tan both sides. Remember, tanning is bad for you, so don't do that. Okay, so tan, inverse tan, they cancel each other out. So we've just got the y over x. We've got the tangent of pi over 3. Okay, well, what is the tangent of pi over 3? Okay, if you said square root of 3, you're correct. If you said something else, I still love you, but you're less correct. Okay, we want to go ahead and solve for y. So we've got the square root of 3 times x. That's just a nice little line. Now I know that square root of 3 for a slope would scare Algebra 2, but let's face it, this equation is far less scary than inverse tangent of y over x equals pi over 3. Come on, you know I'm right. All right, just a couple more. We'll do fewer of the rectangular to polar because it's just going backwards, so it has the same feel. Now, when I look at number 15 here, I've got r equals 4 cosecant of theta. I don't have any little formulas that help me figure cosecant out, so I'm going to change cosecant into 1 over sine. So now I'm going to change that into a fraction. I'm going to cross multiply. And then I know that r sine, that is y. So that, my friends, just a nice little horizontal line. Interesting. All right, so now I'm looking at 16. 16 looks like a problem. It kind of looks almost like our step 2 over here, so I'm going to put that over 1, and I'm going to do the same thing because it worked before. Surely it will work now. And I know somebody out there probably just said, don't call me Shirley. Equals 6. Okay, well this little guy right here is beautiful all in itself. That was y. This little guy, less pretty. 2 square root of x squared plus y squared. Yuck. So that's what we end up with? No, that is not what we end up with. We are going to continue to see if we can get this to look like one of our special conic sections. Seeing how we can't solve it for y, we might as well try to make it look decent some other way. So I'm going to add 3y to both sides. I'm going to square both sides. So that gives me 4x squared plus 4y squared. I just took the square root, well, I squared it, so I got 4 times x squared plus y squared, and then I just took that 4 through. Here I'm going to have to FOIL, so I have 9y squared plus 36y plus 36. Okay, I'm going to get everything to the same side, so I'm going to subtract that 9y squared. So 4x squared minus 5y squared minus 36y minus 36 equals 0. When both variables are squared, one of them's positive, one of them's negative, you got yourself a hyperbola. Okay, so there's our nice, pretty form of our hyperbola. Okay, let's take a couple of these back the other way, and then we'll call it a day. So now we're going backwards. So wherever you see an x, I'm going to put an r cosine in there. Wherever I see a y, I'm going to put an r sine. And then I've got my plus 2 equals 0. Now, in this case, we would want to solve for r if we possibly can. If you can't solve for r, just get everything to the same side. Well, I can go ahead and solve for r. What I'm going to do is take that 2 to the other side. Factor out an r because both terms have it. And then divide by what we have, multiplying our r. Ooh, our r is kind of hard to say at first. Okay, so I did solve it for r. It's in polar form. Nice. Okay, our last one, gonna do the same thing. Y is r sine of theta, so y squared would be r squared sine squared. Minus 8 times 8 times x, which is r cosine of theta, minus 16 equals 0. Okay, I'm not going to be able to solve that for r, so I'm going to leave it just like it is, all on one side, ready to go. Okay, so 9.4 is really just all about the review of everything we did last year involving our polar coordinates. So 9.5 tomorrow is going to be something really fun because we're going to do derivatives and arc length of polar.